There's a concept that's very important to understand for really all languages, and certainly JavaScript is no different. And the concept is passing variables by value versus by reference. And this is what we're going to discuss right now. Now, first of all, what does that mean to pass or copy things by value, variables by value? So the loose definition is that given b equals a, so if you have an a and a b, and you're copying the contents of a into the variable b. So passing, when it's talking about functions, or copying in case of just regular equality, b equals a. So copying or passing things by value means that changing the copied value in b does not affect the value stored in A, and vice versa. So if I change B after I've copied the value of A into B, A stays the way it was before and B changes but does not affect A. On the flip side, passing or copying things by reference means that given B equals A, again we're copying the contents of A into B, passing and copying by reference would mean that changing copied value in B does indeed affect the value stored in A and vice versa. So they're kind of pointing to the same location. Now in JavaScript, the way it works is that primitives are passed by value and objects are passed by reference. Or to say it another way, primitives are copied by value and objects are copied by reference. Now the truth is that underneath the hood in the JavaScript engine, everything is actually passed and copied by value. And the difference is why one is really called pass by reference and one pass by value really comes because of the way the objects and primitives are stored in memory. So let's go ahead and take a look. So here on the left we have primitives, a is equal 7, and then we're copying variable a, or the contents of variable a, into variable b. And on the right, we have a variable a that is equal an object that has a property x to be equal 7. And then in the second line, we're copying the contents of a into b. So b in the end of the day, in both circumstances, ends up with the same value as a, at least at this point. So the question is, how does that work? Let's take a look at some visualization to understand this. So when it comes to primitives, the first thing that happens is we declare variable a and we equal it to 7. So what happens in memory is that a gets memory allocation. In this case, the memory address is 001, and the value that's sitting in that memory is 7. Now when we declare variable b and then copy the contents of variable a into b, what we're doing is we're allocating another memory location, in this case 002, and we're copying the value 7 into that memory location. So then when we overwrite the variable b with the value 5, what we're actually doing is we're placing a different value into the same memory location that b is pointing to, in this case 002. So in this scenario, what you end up with is that A is still pointing to its original memory location 001, which still has number 7 in it as the value in that memory location, and B is now pointing to 002 with a different value. So therefore, A and B really have nothing to do with each other. They really just a copy, or originally were copied one into the other, but at this point, they are not affecting one the other. And this scenario is what is referred to as passed by value or copied by value. So let's take a look at the same scenario, but in case of objects. The first thing that happens, of course, is again we declare an object. In this case, we declare an object literal with the property x7. So what's going on is that A gets again allocated a memory location. Again, in this case, 001 is the address in memory. And what gets put into that memory location as the value is another memory address. So inside the address 001, the value in that position in memory is another memory position that is pointing to another part of memory. And in the address 003 is where the value actually sits. Now, the truth of the matter is I'm actually oversimplifying this. What is actually sitting in the memory location 003 is a list of other memory locations where they have the same type of relationship where it's a primitive now and it's pointing to a particular memory location at which memory location value 7 is stored. But to make this a little bit simpler and not to confuse you further, I'll just say that memory location 003 is where the actual value is contained, or the actual value is stored. So then when we declare variable b and we equate variable b to a, what's actually happening is that, again, the value of variable a, where variable a is pointing to, is copied into variable b. Well, the value is 003. It's a memory location. And it's copied into b, so b now, even though it's sitting at a memory location 004, its value is another memory location with a value of 003. So what ends up happening is they're both pointing to a memory location 003. So finally, when we update b.x equals 5, what we're actually updating is the memory location where b is pointing to, and that is the memory location 003. The value, the direct value of b, still stays the same. It's the value that it's pointing to that is changing. And since both a and b are pointing to the same value, the end result is that both are pointing to a changed value. And this is what's called pass by reference. So the bottom line is the difference between pass by value and pass by reference is that in pass by value, the values, once it's changed, do not affect the original value or the original variable. As opposed to pass by reference, when you change the value and the object that's passed by reference, the original object that's pointing to it is changed as well. So that's the theory behind how pass by reference and pass by value works. In part 2 of this lecture, we're going to jump into the code editor and we're going to see these concepts in action.